Yeah, okay. Welcome everybody. I've been talking the whole day doing the NServiceBus course, so I have to apologize for my voice being a little bit bad, but you know, one more hour talking and a beer afterwards will probably fix it. So, well, welcome everybody for for this night's talk. My name is Andreas Ohlund. I'm the lead developer for a open source framework called NServiceBus. And hopefully tonight we'll go through the new features in the upcoming release, which is the 3.0 release. So before I start, you know, I'm going to talk about the new features. So has anyone of you used the old features? You know, have you used NServiceBus? Yeah, a few of you. So I can't spend a great deal of time talking about the old features, but you know, I'll try to explain, you know, the basics. So you know, don't be afraid to ask questions. I'll try to walk you through it. But obviously, we will spend most of the evening talking about new things that has been added since the current release, which is 2.6. There will be a Q&A at the end. So if I don't cover your questions, you know, please feel free to ask other questions at the end there. And afterwards, we'll be going to the pub like we always do, I guess. I hope you do, Charlie. Thank you. Okay. What's new in NServiceBus? The main goal when we set out to create 3.0 was to get a better out-of-the-box experience. You know, NServiceBus is already quite easy to use. You know, we create queues for you. We try to set most of the things up, but it still requires quite a lot of configuration. So the main goal was to come up with new conventions, you know, to build things that are even more easy for you to use out of the box. That has really been the driving factor for 3.0. So I mean, you'll probably be the judge in a while. Hopefully, we can release it before Christmas. So hopefully, you'll be the judge if we have succeeded or not. So the game plan tonight is we're going to talk a little bit about the storage needs we have and how that will change a little bit in 3.0. We'll see how you, by naming your endpoints correctly, can actually help us apply some conventions to help you remove the configuration needed. So the names of the NServiceBus endpoints will actually have a key role in NServiceBus 3.0. We have done some changes in the area where how we handle timeouts. We'll talk about that. We'll see how you can use the new NServiceBus gateway to bridge remote locations, which is that has become more important. Where some parts of your app will run in the cloud and some parts of the app will run on premise. So we have better support for getting the NServiceBus experience across those physical boundaries as well. I'll talk about some random new features, just going to mention them at the end there, and then we'll round off with a Q&A. So most of you know NServiceBus, but I just put this slide in to give you the basic. I always get the question, what is a bus? If I talk to Java people, they're more a bus for them is more broker, because a lot of the ESPs on the Java platform are rebranded brokers. So I usually like to explain what NServiceBus is by telling it's like Ethernet. It's like Ethernet for applications. So in the same way as Ethernet is not a central thing, I mean, you can't go down to your IT ops people and ask them to show you the Ethernet server. You don't have an Ethernet server, right? You have Ethernet. It's everywhere. It's the cables and the network cards. It's the thing everywhere that kind of enables all your IT infrastructure to talk to each other. And NServiceBus is kind of the same, but it's a high-level abstraction. So, but in the same way as Ethernet, we are everywhere. And NServiceBus is on every machine. So there is no single point of failures. And in the same way as Ethernet has IP addresses, NServiceBus also does. We also have addresses, which means you don't really care, where that machine is physically. When you use Ethernet, you have the IP number, and that might be that physical machine over there. It's the same in NServiceBus. We have also our own addresses, which means that if you want to send a message to the order service, you send it to the order service. You don't really care where it's running right now. We also do similar things like load balancing in an Ethernet network. You might have a load balancer. You would use the public DNS name. If you make an HTTP request over there, you don't really care if it's load balanced or not. You use the DNS name, and the load balancer might decide that that physical machine over there should answer your requests. We're doing the same thing. So our load balancer is what we call the distributor. And we'll see a little bit how that has changed in 3.0. Yeah, so a bus is everywhere. It's helping your applications to talk to each other, to have your order service talk to your billing service. But there are a couple of things that are different between NServiceBus and Ethernet. We have some add-on functionality. We enable you to do publish and subscribe, which means that, of course, we need to store that list of subscribers somewhere. And we have a lot of storage needs. The gateway needs to store message IDs to do the application. Because when you go across between different physical sites, we need to make sure that you're not transmitting the same message twice. So all in all, we have a need to store things. So each endpoint really needs to have a store. So we need to store sagas. Sagas is a way for you to model long-running processes in NServiceBus. You can think of it like workflow foundation, WF, but instead of using XML, we use C# to model the actual process, and we don't do any drag and drop visual tools. So we do code first, C# to model those long-running processes. Of course, having a long-running process means that each step needs to store some state, and NServiceBus is solving that for you. But that state needs to go somewhere, so we need to store those sagas somewhere. As I mentioned, we need to store subscriptions as well. We support durable timeouts. You can ask us for timeouts that will survive restart. That means that we need to store those timeouts durably somewhere. When we use a distributor, we need to keep track of the list of available worker servers out there. So again, we need to store that information. And as I mentioned, the gateway needs to keep track of the message IDs that you're sending, so that when we do retries, we can make sure that we're not creating duplicate messages for you. In 2.6, there are a couple of ways we could store that. But when you run NServiceBus in the light profile, meaning in debug mode, we would store everything in memory. All that would go into memory, which is super good for performance, but it turned out that it's bad for business to have everything in memory. If the server crashes, everything is gone. So the production profile of NServiceBus would actually store that in the database. And in 2.6 and Hibernate was the way we stored things. Usually each endpoint needs to store its things, but there are situations where you need to scale out. So we need to have a storage as well, so that when you do scale out your processing over multiple servers, you need to share that state. So we need to have a store that it can actually be capable of storing. So if you have your if you have your blue app over there distributed on two machines, they need to share the list of subscribers. And of course, they also need to share the saga state. So if they're both processing the same saga, we need to have the saga storage to make sure that we're not conflicting. So that kind of wraps up the storage need. And in 3.0, the storage by default will be RavenDB. So we're moving away from relational databases and then Hibernate, and instead we're going to use RavenDB as our default storage. And our RavenDB is, of course, also a payware product. But if you use NServiceBus, you will get access to use Raven as well for storing those NServiceBus subscriptions, I guess. If you want to use RavenDB for your own database, then you would have to pay the Raven license. And of course, we still support and Hibernate, but it's been moved to separate DLL or separate NuGet if you want that. So if you will still want to use the Hibernate support, you would need to reference another DLL. The reason we switched to Raven is that it's so much easier to work with a document database, storing sagas, updating the schema all the time is quite painful using a relational store. And Raven is super fast, scalable, and it does support DTC transactions. So it kind of makes it a perfect fit for NServiceBus. So that's the default storage. We will bundle it together with NServiceBus, and if you want, we will install it as well. So you can either choose to download and run Raven server your own, or you can ask us to install it for you. So that's a major change in how we store things. RavenDB makes it very easy for you to manage your sagas, so that's going to make a good out-of-box experience. The next part is, of course, getting rid of some of the configuration that you need to have. And we're basing all those configurations off what we call the endpoint name. So if you give your endpoints a good name, we'll use that to kind of. You can of course always go in and override, but we will default all the naming for you based on that name. So could be order processing or bank communication gateway, whatever. Give the endpoint a good name, and we will use that. So examples there could be that the database will create for you in RavenDB. It's going to be named after the endpoint name. So if you have an endpoint called orders, the database name will be orders. The main input queue for NServiceBus will be orders as well. The timeouts, the input for the timeout manager. I'm going to talk a little bit more about the timeout manager in the upcoming slides, but it's enough to say that the timeout manager is now included in the core, so every endpoint will always have a timeout manager running if you want it to. And that timeout manager has a special input queue, and that is also defaulted using a name. Every endpoint will also have a gateway running, which means that you can talk to all the endpoints now using HTTP if you want. That URL will also default using the endpoint name. There are a couple more things as well, around the distributor. So a lot of the stuff we do will be using the endpoint name as part of the convention. So hopefully by doing that, we can almost have you run without an app config at all. Everything could be done by using conventions instead. There are a couple of ways you can name your endpoints. The first one is that the namespace of the endpoint configuration will be the endpoint name. So if your endpoint configuration class is in a namespace called orders, then the endpoint name will be orders. You can of course also use an attribute endpoint name. And you can also set the name when you do install the host. The host that comes with NServiceBus can be installed to run as a Windows service. And when you do that, you can actually pass the name in there. And of course, finally, you can define your own convention. So you can configure NServiceBus and use the define endpoint name. In there, you can pass a func of t, which means that you can, come up with whatever convention you would like to have there. Any questions so far? So. I don't think so. It's okay for URLs and it's okay for queues as well. So no, I don't see, and RavenDB can have databases with dots in them. So no, you can have that as well. The question is that when you do update to Saga instances, what would you need to do? If you remove things, that won't be a problem because Raven will handle that anyway. If you add new stuff, you need to take the same care as you do with relational databases. You need to allow nulls first. And if you can't allow nulls, you need to add it in there. You need to run some update scripts in Raven to actually set the new values. But if you can do it, a step-by-step migration, then you wouldn't need to do anything. So it's not so RavenDB is not a magical silver bullet that kind of makes all that hard IT work go away. So when you change, the schema of things that you have persisted, you need to think about the implications. So if you add a new property called first name and you require that one to be not null, then yes, when you do the deploy, you need to make sure that all the existing sagas in there will have a first name that is set to something. Actually, I'm going to do a demo real soon, right now. So hopefully I'll answer it there. Okay. So the first demo is going to be just storing a saga inside RavenDB. Can anyone see okay? Yeah. So in here I have a classical definition of the NServiceBus saga. You inherit from the base class saga, and in the generic argument there, you pass in the class that will define your data. So in this case, the data we'll store for this saga is the ID. The first three ones are required by the NServiceBus infrastructure. We need to have an ID so that we can identify the saga. We also need to keep track of the address of the endpoint that started the whole saga off. And we also keep track of the original message ID. That is so that we can correlate back. So if we have people that is using callbacks, then want to be notified when the saga completes, we keep track of that in the sagas to make it easier for you. But in there I added my own order ID. It's a GUID. So that's the data part of the saga. This saga is just started by a message coming in. It's called a start saga message. In there I will set the order ID and I will request a timeout. So we'll talk more about the timeouts later. So if I run this one, firstly I haven't specified the name here, so it's going to pick the name from the endpoint config. And the endpoint config is in a namespace called my server. So the name of this endpoint is going to be my server, right? So I have no queues on my machine, and my RavenDB is totally empty. It's a fresh Raven. So the only thing is in there is the default database. So let's start the endpoint up. So it's going to create the queues for me. So if we take a close look at the queues now, we'll probably have some queues in here. We have the arrow queue. We have a queue called my server. Again, the main input queue of the server will be using the same name as endpoint. I've started the timeout manager because I'm going to use the timeout manager to send timeouts to my saga. And the input queue of the timeout manager will be my server.timeouts. Yeah, so let's take a look in RavenDB as well. See if we've got something in there. Yeah, we've got a new database now called my server. Let's use that one. It's probably going to be empty now. No documents in there. So let us create a saga. So in this case, I'm sending off a message to create a saga. So it's started saga and requested a timeout. So let's take a look in RavenDB and see what we got there. Documents. Oh, I need to type to user. now we have two documents there. We have the timeout data, because as I said, NServiceBus is storing the timeouts, and we have the simple saga here. So let's take a look at it. Let's see if we can zoom. So this is what's stored in Raven. The ID at the top here, that's the ID of the saga. You have the originator, the one who started all off. That's my server. I started the saga myself, so it's my own address. And I have the order ID in there. So it's pretty easy to add new things in there. Let's stop the saga and create something new. Let's do data dot status equals new. And we ask Sharper to create it for us. So we just create a new property here. Hit F5 again. Send the message off, and hopefully we have a new document in there which now has the status new. So it's fairly easy to add new things in there. Which is good. We don't have to think about the schema in the database as much as before. And if we look at the configuration of the endpoint here, you'll see that the only thing we have in there is that we're specifying where the arrow queue is. So we're not specifying any inputs or anything. The only thing we don't want to default that one because we want the arrow queue to be on a central machine somewhere. So we're probably going to come up with a convention there as well, but for now you need to specify where the arrow queue will be. That is the queue that if something goes wrong, that's the queue where NServiceBus will store those messages that can't be processed. But we are at least down to effectively one line of configuration now, just by having you specify the endpoint name. So if you're upgrading from 2.6, you probably want to specify the endpoint name to have the same name as your current input queue. Any questions so far? Yeah. Yeah, I mean, you'll query Raven with whatever tools. It's very easy to build indexes and query it, but yeah. It's more a question: why would you like to query that Raven store? Yeah, yeah. I think sagas will have a if you listen to people like Udi Dehan and Greg Young, they at least Udi is talking a lot about that sagas will sooner or later become your domain model. So sagas will play a bigger part in the future. At least, that is what I think. So, sagas are very useful for everything, from infrastructure things up to business logic. Okay, so let's move on here. Next part we'll talk about is the timeouts. In 2.6, you had to run a separate timeout manager, which was a separate NServiceBus endpoint. But in 3.0, that is actually included in the core. So even if you don't use the host, or even if you run it in a website, if you want, you can turn the timeout manager on. Because there are some very useful things you can do with the timeout manager. But the way it works is that within the same endpoint, if a message comes in and you ask for a timeout, another message will be sent to the input queue of the timeout manager. That is by default called timeouts. The timeout manager will pick it up. It will store it in a data store. It could still be in memory, in a MSMQQ or in RavenDB, as we just looked at. And when the time is up, let's say you set a timeout for 30 days, because after 30 days, you would re-evaluate if this customer is still a gold customer. When the time is up, the timeout manager figures out and it sends a message back to your main input queue, effectively. Have you seen the movie Memento? When the guy keeps forgetting things and is writing it on his arm, that's kind of the same thing here. But instead of writing on your arm, you send a message to the timeout manager saying, hey, in 30 days, can you please, send a message back to me? And the data in the message should be this. So effectively, you're sending messages to a future version of yourself, which of course is very useful in Sagas, but as we'll see, it can be very useful for other things as well. The API is pretty much the same as in 2.6 with a couple of minor tweaks. You still request the timeouts by using request UTC timeout. We put UTC in there because we had a bug, so we had to create a new method. That's why we have UTC in there. Because if you don't use UTC times and you have servers that span different time zones, I promise you that there will be trouble. So we still support the 2.6 timeouts, but in addition to that, you can also implement a new interface called I-handle timeouts. In 2.6, the only thing you could pass as a state was an untyped object. But in 3.0, you can actually pass an entire message as the state, which is, you can work with strongly typed objects instead of a object. We have one new method. It's called bus.defer. Essentially, you're saying that here is a message. I want to handle this message in 30 days, in 1 year, in 30 minutes, whatever. It could be useful in scenarios where perhaps you have a sign-up process. So when the user signs up, you say that in 6 days, send a message back to me saying that I should remove the account if it's not, if the email is not verified. So it becomes kind of a lightweight Saga, because there are many situations where you want to do simple things like that. So when the message comes back in 6 days, you take a look, see, has the user verified his email? If he has, then well, good, we don't do anything. If he hasn't, we'll delete the account or whatever you need to do. With this kind of functionality, you really don't, if you design things correctly, you really don't need any big batches running anymore. Instead, you can use timeouts to kind of do things at the time when they should be needed. For example, if you upgrade a customer to a gold customer, you can set the timeout saying that I should reevaluate him in 3 months, or whatever your business rule says. Because working with time is, that's also always a crucial thing out there. The business there are always business rules saying that, in every 30 days we should do that, and so timeouts can be a really useful thing. And as I said, all the endpoints have a timeout manager inside of them, so you can decide to turn it on if you want. Not as much, because everyone will have the local timeout manager, so you don't need to make it highly available. It all depends on your SLAs. If you have a tight SLA saying that this online auction must be closed within 1 minute, then you can't have that really on one server. So you could still keep it on 2 servers, but you probably want to use the distributor. In that case, you would have to have the timeout manager running on a clustered machine. I'm actually going to talk about that in a few slides, so hopefully I'll cover it then. Yeah, so let's take a quick look at using bus.defer. So it's the same sample. Where is there? Yeah. So in essence, what I'm going to do is I'm gonna send a message. I'm going to do the bus.defer, and I'm gonna say that in 10 seconds I want this message to be sent to me so that I can process it. So that message is just a regular NServiceBus message. So you can either specify a time span saying in 10 seconds, or you can specify a exact time saying that, on New Year's Eve, 11 o'clock New Year's Eve, send me an email reminding me that I should, stay sober enough to say cheers to my wife. Okay, so and of course to process that message, the only thing you need to do is to have a regular NServiceBus message channeler. They'll react when that message comes in. So we'll run that endpoint. I sent the message. It's now sitting inside the timeout manager, which it's keeping track of time for us. So when the time is up, 10 seconds, it's going to send the message back to us, and hopefully I'll process it, which I did. So deferred message processed. And of course, the messages are durable, so if I send another message, that was a Saga message, sorry. I send another deferred message and I kill my endpoint. So if I restart now, if I wait a while and I restart, that message channel will still fire, because the timeout manager are storing those messages durably inside RavenDB in this case. So if I start it up again, it will be processed now. A little bit too late because this took longer than 10 seconds. But it will still be processed. I hope. Yeah. There you go, deferred message processed. So durable timeouts is really, really a important feature that can help you build your business logic. Questions so far? Okay. Let's go back to the slides. The next part I was going to talk about is bridging remote sites. Having remote sites are becoming, a little bit usual this time, because you might decide that I want to run some number crunching servers over at Amazon because I get cheaper hardware over there, but I still want to run my own stuff on premise. Other situations where we would have multiple physical sites is, for example, if you have your headquarters that needs to synchronize inventory with the national warehouse, with all the stores out in the country. That's also a usual scenario where you have different physical sites that needs to be talking to each other. In those cases, you would use the NServiceBus gateway to communicate between those sites. So on each local site, you would use NServiceBus, and you would use the gateway to kind of bridge the gap there. Use HTTP or FTP or Azure queues or whatever transport channel needed to get the data across the sites. So you will use the gateway for scenarios where you can't set up a VPN. If you can use a VPN, just configure it and use MSMQ as usual. But if you can't do that and you need to use another transport, then you would use the gateway instead. And the way the gateway works is that if we have a headquarters sending a message, it will go inside a queue exactly the same way as the timeouts. It will be picked up by the gateway. And that gateway will send the message over to the gateway on the other side, doing the handshakes and deduplication, making sure that you're not sending the same message twice. It also takes care of retries. If the other side is down, it's going to do retries and things like that. And then when the message reaches the other side, that message will be sent into the input queue of the app on the other side, which will do the regular processing. So in 2.6, that was a separate process. In 3.0, it's included inside the core. So there is a gateway everywhere. So So in short, it's there to bridge multiple physical sites. It can listen and use multiple channels. You can have FTP over to that site, and you can use HTTP over to another site. It does deed application and retries. And it actually gives you a separate channel into your endpoint. So you can use that thing to control the number of worker threads in your endpoint. So you can set the number of worker threads to 0 if you want to temporarily disable your endpoint. So it becomes almost like a administration entry point. And it also now enables you to do browser interactions with NServiceBus. So that enables you, if you build one single page apps, you can have your static content on a CDN. All your commands will be sent straight from your web browsers into NServiceBus inside the gateway. It will get processed, and you might read the data straight from RavenDB. So you can build applications that doesn't have any, no ASP.NET MVC or anything in there. So a quick demo of the gateway. Oh, it's loading user settings. For example, we have a headquarters sending price updates to two remote sites. So in this case, we have the headquarter who's responsible for every morning it pushes out the price update to its remote sites. The API you would use there is it's a new signature. It's called bus.send to sites. So this is a very explicit concept in NServiceBus. In there, you pass in what we call site keys. You can either use a convention so that the site keys will be HTTP addresses if you're using HTTP, or you could use another. The other way is to actually have a configuration entry for each of those sites. So let's take a look at the app.config here. So in this case, I'm just saying that site A is running on my localhost /site A, and same for site B. That is how the headquarters know where to send those messages. So if you start it up, so that was the headquarter. Let me close down some crap. So we have site A up to the left. We have the headquarters at the bottom, and then site B here. Right. So if I send a message from site A, return. Sorry. So now it's sent it. So now the gateways will do a handshake. So the message will be received. So site A did receive a price update from the headquarters. The same did the site B. And site A is also going to do a bus.reply. So the gateway is actually supporting request response. So if the site is doing a bus.reply, we will rewrite the addresses and figure out that it should go back over the gateway back to the headquarter again. So the gateway supports the regular message interactions. So we do request response. We don't do publish and subscribe across physical sites, because cross-site communication is usually done within one business service. And inside there, request response is good enough for you. It's usually because it's a little bit more involved to support publish and subscribe across physical sites. So as you see down at the headquarter, I'm printing out that the price update was received by site A, because site A sent a reply back to me. So I also have a HTML page here The only thing it's doing is it's creating a. I'm using the XML serializer in NServiceBus, so this page is just creating a XML message, generating a GUID, and it's calling, making a JSONP request down to my headquarter. So you see the URL here is localhost/headquarters. So this could be a single page app running, this runs at the client in the client's browser. So with the gateway in place, you can actually send things to NServiceBus without going through any things like ASP.NET MVC or something like that. So if I send it to the headquarters, we'll hopefully get something here. Yeah. Price update received from web client. So you can now you can actually talk to NServiceBus from your browsers as well, which I think, I see a lot of more people building one-page apps. So I think this might be a handy thing to have going forward. Of course, by having a gateway everywhere, you can actually browse to your endpoints. Let me do that. So let's first of all browse to the headquarter. So by default, if we get in requests that are not gateway communication, we will just return OK. But we actually made a extension point for you, so you can actually plug in your own handlers. So if you want to return special data, or if you want to accept commands coming in over HTTP, it's very easy to do. So the sample is doing that. So if you look in site A here, I created my own, we call it HTTP responders. So I created my own HTTP responder. And in there, the only thing I'm doing is just I'm creating a HTML page, and I'm invoking all the endpoint inspectors that I have been registered. So that's just an interface I came up with. So, and those things can do things like, in this case, I'm figuring out the address of the audit queue, and I have another one that is displaying the number of threads that the current endpoint is using. So this is just read-only things. Of course, you can accept commands as well, adjusting number of worker threads. You can turn auditing on and off, things like that. So this could be a good way to do management stuff. So if I browse to site A, I will get something else. I'll get the number of worker threads that site is using. So in this case, it's using one worker thread, and audit is turned off. So I could see that the community could, there's probably going to be some community additions here where you can plug in health status things. Again, just a teaser. Well, it's up to you to see if you like the features and build something. Any questions around the gateway? I'm just scratching the surface here. The gateway is a big concept, but at least you know what it is, and so that you can dig deeper. Yes. The question was if the gateway works on Windows Azure. NServiceBus runs fine on Windows Azure. I'm pretty convinced that the gateway will run as well, but I'm not an Azure expert, so you would have to ask if. So that's a good point. But at least, I could see you would use the gateway to perhaps have the gateway use Azure queues. So if you're sending, let's imagine that you do some kind of expensive image processing. You would use the gateway to transmit that thing out to Azure, where it will be processed and sent back. So at least you would use the gateway to bridge your on-premise solution with the things that will run in Azure. But I think it will work over there. Could be that the Azure firewall is doing some strange things, but I would demand that you could easily get it to work. Yep. Now we support Windows authentication, but you can easily extend and plug in your own, because if you're coming from a single page app, you're probably going to use OAuth or something like that. There is no native support for OAuth, but you can easily write your own message handlers. They'll do the OAuth authentication for you. But supporting OAuth and other authentication mechanisms more natively is definitely on the roadmap. So it's going to hopefully make it for the release after 3.0. RavenDB, of course, supports OAuth, so it's possible to talk to RavenDB straight from websites and still have everything secured. So let's hopefully you stay awake for a couple more slides, and then we'll do Q&A. We have another we're introducing another concept as well. It's called a master node. When you do things like scaling out in a service bus, you would like to have your distributor on a cluster, because it can become a single point of failure in terms of SLAs. Everything is queued, so you're not going to lose any messages if the distributor is down. But what will happen if the distributor is down? You end up breaking your SLAs, because if the distributor is down, you're not processing any messages. Which means that if you have an SLA saying that order should be processed within 1 hour, and if the distributor is down, you might risk breaking that one. So, therefore, we have the concept of a master node, because configuring the distributor can be quite tricky. So, you tell an endpoint it's the master node by specifying a profile. It's called master. So if you start up an endpoint with a master profile, it knows it's the master node, and by default it will start the distributor, you start the timeout manager, and it will start the gateway. You can of course turn them on programmatically, but the master node will have those running. On the other machines, you configure those machines, tell them where the master node is. You tell them that this is workable too. Your master node is my cluster. Same goes for worker number 1 there. And that's the only configuration you need to do to scale out. Because by doing that and starting them up with a worker profile, that means that they will automatically check in with the master node and sign up as workers. So instead of adding that tricky configuration you would need to do to scale out, the only thing you need to do now is configure where the master node is and start the workers up in the correct profiles, and everything should work for you. So that is how you would use the master node to scale out with less configuration. So that means that the configuration for those worker nodes will be identical. So you can have pre-configured VMware images just waiting, and when messages start to back up in your queues, you can start up new instances on the fly, and they will just wake up and check in with the master. So you can use that to kind of get elastic scaling, even if you run on-premise. So that's the concept of a master node. Again, it's an attempt to make it even easier for you to configure NServiceBus in scenarios where you want to scale out. The final thing I'm going to talk about is a data bus. If you use MSMQ, the limit of message size is 4 megs. That is usually not a problem. It could be a problem if you're sending, messages containing large images or videos to be processed, things like that. It is a problem when you run on Azure, because Azure queues only takes, I think, 84 Ks. I think because it's using base 64 encoding, I think in practice it's only 68 kilobytes something, and that message size could be a problem. So we solve that for you, that if you have properties that on your message that you know will be large, you can configure a separate channel for us to use instead. So in the Azure sample, you can use Azure queues to transport your messages, but the payload of your images and your videos, they'll go on a separate channel, perhaps the blob storage, something like that. So the only thing you need to do is configure that in NServiceBus, and we will take care of it for you.
How do we say this property is going to be too large?
Do that by specifying a special property. It's called a databus property in there. You can pass in, if it's a string that is large, or if it's a byte array, whatever. And when we see that property, we're going to make sure to transmit that data over the databus instead. So on-premise, that could be a file share or something like that. It's just to help you work around the limitation of the queuing systems. So you as a developer wouldn't really see the difference, because when the message gets to your message handler, all the data will be there available for you. So that's the data bus. A couple of other features just to wrap it up. In 2.6, to create your message definitions, you would have to reference a NServiceBus DLL. And that could be a problem, because if you're publishing an event and you want to upgrade the version of NServiceBus, you would need to upgrade all the subscribers in one go, which could be, if you're a large corporation, that could be a dangerous thing. So in 3.0, you can actually run in, I don't know if it's a good name, I call it unobtrusive mode, which means that instead of implementing the iMessage marker interface, you would instead give us a convention saying that all messages in a namespace that ends with messages are your messages, which means that you don't need to reference any NServiceBus DLLs, which means that you can upgrade NServiceBus without risking having incompatible messages. So instead of using marker interface, you would use conventions instead. So that's going to help you help the versioning story. In 3.0, we're also using semantic versioning for our DLLs, so that will also make it a bit more easier. So we're only going to bump the assembly version when we either upgrade the minor or the major version. So we're not going to change the assembly version on every build, on every patch, following the semantic versioning standard. But still, if you want to be totally free of reference to anything else, then you could easily run NServiceBus in unobtrusive mode instead. I already mentioned the databus property. The other one is that, one of the main things we did in 3.0 was to make it more easy for you to plug in your own transports. In 2.6, you would implement something what we call the iTransport, which means that you had to take care of all the threading, all the error management, everything. But in 3.0, we have two new interfaces, iSend messages and iReceive messages, which makes it a lot more easy to plug in things like RabbitMQ, ZeroMQ. The support for Azure queues is just a matter of 50, 60 lines of code. So in 3.0, it's much, much easier to plug in other queuing systems as the transport. Another thing that we have now is modeling tools. It's an attempt to make it easier, at least to get started, to draw out your architecture. So it's a tool that will give you one-way code generation. Essentially, helping you to sketch out the first draft of the solution and get the project set up and configured. So I guess we'll see what will happen in the future there if we improve on them or not. Another small detail that is, has been really wanted is the exception details in 2.6. If you want to know why a message ended up in the error queue, you would have to go and scan the logs to find the log entry with that ID to kind of figure out, oh, so that message is in the error queue because we were out of disk space on C. In 3.0, we're actually attaching those details as headers in the actual message, which means that you only need to look at the message in the arrow queue, and you can see, okay, why did this message fail? We were out of disk space on C. We need to send get an operator in there and plug in another disk drive. So again, it's a minor thing, but that's been a pain for a lot of users. So another thing we have is a client-side pipeline. In 2.6, the only thing you could react on, you can plug in things in the server-side pipeline. Now you can actually add hooks on the client side as well to do things like, before we send the message out, I want to do a data annotations validation of the actual message. So you can plug things in on the client side to do validation. You can plug things in to mutate the message to do, you can encrypt the message better, you can zip it. You essentially get a way to plug in on the client side when the message is being sent. So it's especially good for validation. Well, that's pretty much all the features. So let's do a Q&A. So the question is, what will happen if the data bus is down when you do a send? When you do a send, if you can't talk to data bus, you'll get an exception when you're sending. So it's pretty easy on the sending side. It's more problematic on the receiving side. So let's assume that we actually managed to send the message. And on the receiving side, we pick in the message up from the queue. We see, oh, it's a data bus property. It's a big image. So we go out to the data bus and say, get me, the item with ID 54. And the data bus is saying, I don't know, I don't have that. What we'll do then is that we'll retry the number of times, just like usual. And if it still fails, we're going to move the message to the error queue. So then it's up to you to say, okay, why is that message not there? Oh, it was a 54 gigabyte movie. It's a long movie with bad compression. So it might take a while. So perhaps you have to retry that one in 30 minutes, something like that. No data will be gone, because the application message will be in the error queue, and the data in the data bus, we sent it successfully, right? So hopefully it's on its way out there, or so hopefully nothing's gone. Sorry? Yeah. So the question was, what happens if the data is orphaned, meaning that there is no one there to pick it up, right? Yeah. So that's why when you implement the data bus, the semantics is that you should do your own cleanup periodically, going through. And so, for example, the file share data bus sets a timestamp. So so you can configure it to clean up entries older than X hours, X days, things like that. Because the problem is, we can't, NServiceBus can't really know how long should we wait. I mean, when should we consider it to be orphaned? It could be, is 5 hours long enough? Oh, it could be okay, right? So you as a user need to configure the data bus implementation to clean itself up in order to save disk space or whatever. Okay, good. The question was how you set up the unobtrusive mode, right? So let's take a quick look at that one. There is an unobtrusive sample if you want to take a closer look. Okay. Client. Oh, it's a long. Let me do some. So this is how you define your conventions. So in this case, we're saying that the commands are classes that has a namespace that ends with commands, and events are. I'm gonna explain what commands and events are in a while. And you define that events are classes that ends with events, and messages are classes that ends with messages. So that is how you define the convention. Right? And we also have conventions for things like encrypted properties and databus properties. So in this case, I'm saying that all the properties there, where the name starts with encrypted, should be considered encrypted properties, because NServiceBus supports encryption as well. So essentially, that is how you run in unobtrusive mode. Yeah. I forgot to mention, another new thing we have is that we have a way for you to specify what is commands and what messages are events. Because then we can help you enforce the messaging best practices. So you're not allowed to publish commands, because commands should be sent to a single endpoint. So you're not allowed to publish commands, and you're not allowed to send events. You're not allowed to subscribe to commands, you're not allowed to unsubscribe to commands, things like that. So we have two new interfaces, iCommand and iEvent. So if you implement that on your messages, we will kind of try to create the pit of success for you. So we try to help to guide you how you should use your messages. Yeah. Did that answer your question? Yeah. I paid him to ask that question, so it's good. No, it's yeah. I mean, following the messaging best practices is important. So yeah. So we try really hard to be backwards compatible. So the first thing is, of course, that you need to name your new endpoint so that you get the same name on the input queue. Other thing is that when you subscribe to messages, we enforce semantic versioning there. So if you're subscribed to version 1.0.0.0 message, you will stay subscribed even if you only bump the last version. You will still stay subscribed, because according to semantic versioning, if you only bump the last, I think it's called the patch, then you by definition are still compliant. So only if you change the major version of your messages, then you will be considering then you need to resubscribe again. So that's one difference. No, I mean, we do support we do support everything. So it's mostly configuration changes. It shouldn't be any code changes at all. We have gone to great lengths to trying to ensure that going from 2.6 to 3.0 should be as painless as possible. Well, yeah, I think there'll probably be some gotchas yet, but we'll try to fix them as well. So, but of course, please test this out in your acceptance test environment first. Content-based routing. Yeah. So the question is, can we plug the distributor to do content-based routing? Well, it's a long story. Using a bus, you shouldn't really be needing content-based routing. You should use explicit messages instead. So if all the strategic orders are special, you send them, you have a special message for it. But that said, you could build, of course, your own endpoint, feeding messages in, looking at the data, deciding where to send them. So it would be very easy for you to build your own content-based router. It's just an endpoint, a message handler, look at the data, decide where to bus.send it next. So it should be trivial for you to build one yourself. If there isn't anything else, I just quick run through all this. There are a couple new samples in 3.0. We have a new MVC3 sample for the async pages, which demonstrate how you can use the async feature in ASP.NET to do non-blocking operations to save web server threads. There's a couple of Azure samples that shows you how to run NServiceBus on Azure. Database sample, gateway sample. We have a sample for the unobtrusive mode. And we have a Starbucks sample. Everyone needs to have a Starbucks, which we tried to find a name that would be like NServiceBus, but it didn't work, so it's just Starbucks sample. I don't ever have any more slides, so we can head off to the pub, I guess. If you want to, if you want to know more about NServiceBus, NServiceBus.com, or go to my blog. I've been trying to blog more about 3.0. My backlog of blog drafts are, I think WordPress is going to crash on me soon. So. And on Twitter, I'm at Andreas Ohlund. So just ping me if you have questions, and we will have 3.0 out very soon, so that you can use it for real. Push the beta out to the main NuGet feed. Hopefully next week. So right now we have 2 feeds, one for the CI and one for the main feed. We're going to remove the CI feed because NuGet as of 1.6 is actually starting to support both pre-release versions, and I think they're going to support build versions in 1.7 or something. So we are going to start push everything into the same NuGet feed. Thank you. Thank you for coming. Yeah.